Okay, this is part two of the coding kata for bowling. And I've done the simple games where you just add up the pins, and now I'm going to start to do some spares and strikes. So let's continue. So first I'm going to move this guy onto the... Well, I won't refactor that. Actually, let's just continue on. So we need a test for a spare. So we'll copy this guy. We'll call it test roll spare. Okay, and then what does a spare consist of? Well, player's going to roll a ball, and it's going to be a 5, let's say here. And then he's going to roll another ball that's a 5, and then he's going to roll another ball that's a 1, so he gets use of the spare. And then all the rest of the balls, he's going to get a 0 for it, and there's going to be 17 of them left. And then the score will be 12, because it's 5 and 5, because this guy, it's a spare. This one will be counted twice, so that'll give us 12. So let's give it a go. It should fail. And he does. It fails. Now it turns out there's a trickiness to getting this working, because actually what's happening is in order to do spares, you'd like to sort of go if spare, add up, the last 2 balls or something like that, and add up the one for the next frame. You'd like to do some sort of if, but there's a misplaced responsibility here. This guy is calculating the score when he really should just be keeping track of the pins. So let's do something like this. We'll keep an array, so we'll go rolls, and we'll have a counter. So it's a ball number, and then it'll be plus plus because we'll increment it after we fill it, and we'll put number of pins in it. There we go, number of pins. Score is not being touched here. We need this variable, so we're going to create the field, ball number, okay. And then, actually maybe we'll call it roll number, but that's okay. Actually, why don't we call it roll number? Because we're calling everything that, roll number. Okay, now we need the array to put it in, boom. We're going to create a field again. So that's our array. Actually, at most there'll be 21 balls that are ever rolled. 2 for each frame, except for the last frame, which could give us 3. So now we have the number of balls. Actually, we're going to disable this test while we're doing this because I'm about to make sure this refactoring here doesn't break things. And now we have to calculate the score. So there won't be a variable anymore for the score. There'll be something like all the balls, so 4 each, and then it'll be all the number. Whoops. We'll go over all of the rolls. Whoops. What happened there? Try that again. So, okay, and then we're going to loop over all the rolls. And we're still going to count all the pins. Okay, and so score plus equals rolls, and then whatever roll number we're on, right? And this guy is undefined. And so we're going to create a local variable for him. That's cool. He's an int. He's going to start with 0 to start with. If we got everything right, this should still work. Yes, it did. So super. So now we get everything okay. Let's see if there's anything about this we want to change. We're not going to refactor anything yet because we want a green. We want to get this failing test and then fix things. Okay. So this test, the roll spare should fail. Cool. It fails. Now, we've got our concerns separated. This guy tracks the balls. This guy figures out the score. But actually, we don't want to loop over the balls. We want to, because we're doing spares and strikes, we're going to have to remember what frame we're on. So actually what we're going to do is we're going to make I an outside variable, and that's going to be the ball number. But we're going to count frames. And we're going to go frame, and there's going to be 10 frames. And we're going to go frame plus plus. And then what we're going to do is the score is going to be, right now we're just going to add all the pins up in every one, and there's always 2, so it's I plus 1. So that's cool. And we have to advance this I counter by 2. So because every frame takes 2 balls still. Okay. And actually, this is still a refactoring. Okay, so I disabled the test again. Make sure I haven't broken anything. And it still works. So super. Now we're close. Now we can re-enable this test and really try to get this spare to work. Okay, so that's good. It's failing. So now how do we add things up? Well, now we can put our if statement. It's kind of like this. If roll. Oh, actually, why don't we create a variable? Well, we'll do it this way. If roll I plus rolls I plus 1 equals 10, then how's our score going to work? Our score is going to be 10 plus rolls I plus 2. And else, our score is just going to be the sum of the pins. In all cases, the frame still continues to 2 balls, so that's good. So let's check that out. If the rolls I plus 1, I plus n, blah, 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 equals, does that make it pass? Aha, passes. Super duper. So now we've got our spare. So now we're on the green part, refactoring. So it's kind of like this guy here is ugly, isn't he? So we're going to extract a method and say is spare. Yes. Okay, and this I thing is also ugly. So we're going to go first ball in frame. That's the name we're going to pick. Okay, and so that's cool. And so now it's looking a little better. Yeah, I've got the unused. Let's make this guy. So I'm checking to see all the little errors here. So I've got this disabled guy. I'll remove him from it. Oops. So let's see. Somehow I did that. Okay. Cleaned up my imports. Nice little green thing up in the corner here. And if I'm still good after all that refactoring, I should have a spare. Okay, so you can see, you can kind of guess the pattern here. I'm going to do the same sort of thing for the strike. Boom, like this. And it's going to be roll strike. And then he's going to roll a 10. And then he's going to roll this. And actually, the score here should be, and there should be 16 balls left. Okay, because he's got, oh yeah, we need 2 of these. Actually, 2, because it's a strike. We want to roll 2 more balls to make full use of our strike. And actually, these 2 balls are going to be counted twice because they're strike. So this makes it 14. We run this guy. And our strike fails. And I spelled strike wrong, so let's fix that. And our strike fails. So we're red now with a strike. Good. So it's the same sort of deal as before. Just another L. We do else. We're going to add a if. And in this case, it's rolls I equals 10. actually, and its first ball and frame equal to 10. If it does, then we have to figure out how to do the score, right? So first ball and frame, blah, blah, blah. So actually, how does this work? It's going to, well, there'll be a 10, and then there'll be the 2 and the 1 after it. So this should be how the strike works. And let's see if that works. Did I get this right? Oh yeah. Now, oh yeah, this guy, next ball. This is our first time with a frame that has only 1 in it. So these guys now have to have, okay, it's first ball and frame. It's 1, and this is first ball and frame. It's advanced by 2. And then we duplicate this, move it down a little bit, boom, get rid of this guy. Now it's starting to look right, is it? So we run it. Yeah. So that's all working now. And now we need to do some cleanup. So just like before, extract a method, and we'll say is strike. And we'll keep the original guy here, okay? So now we've got an is strike method. That's super. Rolls balls, okay. And then this thing here, it'd be nice if these guys were a little bit, like this is actually a spare. So we'll extract a method and we'll call rolls spare. And keep our original. And then we'll call this one rolls strike, just to make it more descriptive. And let's make sure our tests, look at our tests again. Rolls many balls, 0 to 20, rolls 1 to 20, rolls a strike, and then rolls a spare, then rolls a 1, and then rolls strike. So let's move this guy down here as one of the helper methods. There we go. And then roll strike, and then rolls these 2 balls. Okay, so let's look. Okay, this is a good solution. First, it needs maybe, I'd clean it up a little bit more and do some refactoring, but this is not a bad solution. So let's stop there and do a part 3.